Hello, and we're back for another circuit to solve. The total resistance is our first question that needs to be answered. And we have 5 resistors in this little circuit, an 18-volt battery that's powering it. So, first thing, we need to identify what's in series and what's in parallel with each other. That's handy. And we should be able to see pretty quickly if we kind of do the color coding thing with the voltages, right? So anywhere you can go through just wire, the voltage doesn't change. So all that's the same voltage, and all this is at the same voltage, and all that's the same voltage, and lastly, all of this is at the same voltage. So if we look around, we see that we've got a couple of pairs of resistors that have the same potential difference, voltage difference across them. R1 and R2 can be combined in parallel, and R4 and R5 can be combined in parallel. So let's get to it. R1 and R2 in parallel get us this, and R1 is 100 ohms, R2 is 50 ohms, and so, that's a 5, I swear. And then we get a common denominator of 100. That gets us 3 100ths. And if you work through, you should get 33 1/3 ohms from that calculation. Okay? Now, we can also combine 4 and 5 in the same way because they are in parallel with each other. They are different resistances though, right? 250 and also 75. And in this case, when you combine those fractions and you flip things over, here I'll do it live, okay? Then you should get something that's handwriting. You should get 57.7-ish. I'll keep an extra couple of digits. Okay. And then once you simplified those two, so this little block and this little block, well, then those two blocks are in series with R3. And so we can simply sum R12, R3, and R45, which gives us those two numbers plus R3, which is 50. So altogether, you're getting 141 ohms total resistance. Okay, so that's part A. Now, for part B, the question is, what is the voltage difference across R4? Okay, so R4 is over here, part of this R4, R5 combination. And so we know that whatever the voltage difference is across the combination, it has to be equal to the individual resistors' voltage differences because they're in parallel. All right. Well, we don't know the current going through R4, but we certainly know the current going through their combination, right? There's no way to get from one end of the circuit to the other without going through the combination of R4 and R5. And so that's getting the total current in the circuit. And we multiply that by R45, and we will get the voltage across the combination, and thus across the thing that we're looking for. Okay. Now, these numbers, well, current we haven't actually calculated, but it's really easy because we've got total voltage and we've got total resistance. So we can just substitute for that. And R45, remember, is this 57.692 ohms. And so we divide 18 volts by 141 ohms. We multiply that by this number, and we will get, in the end of things, 7.36 volts. Here, let me double check that by taking this, dividing it by that, and then multiplying it by the other thing. Okay, yeah, checks out. And that, because of what we talked about above, has to be equal to the voltage difference across R4. Done. 7.36 volts. Now, part C, what current is flowing through the solid dot in the diagram? Okay, so the solid dot in the diagram is after the two currents that split off and went through R1 and R2 have come back together, right? We're right there in the diagram. And so the total current is going through the solid dot. So I should write out solid dot current, question mark, but we can answer it so quickly. Okay. We already did this for the problem above. It's 18 divided by 141, which is this many amps. Done. All right. Hopefully that all makes sense. See you for the next one.